In this video, we are going to look at the nuclear decay practice sheet, starting with determining which isotope is most stable. So we know that for stability, we are looking for a proton to neutron ratio that is close to 1. And that information is provided in the paragraph at the top if you've forgotten. So when we look at the list of isotopes, we're just going to start by determining the proton to neutron ratio. And then once we know that, we'll be able to figure out what the most stable isotope happens to be. So we have carbon-12, carbon-13, and carbon-14. If we look at a periodic table, we know that all of these isotopes of carbon have the same number of protons. All carbon has 6 protons. But these isotopes differ in the number of neutrons that they have. And so we'll kind of make our ratio in table form here. So 6 protons, carbon-12, that would mean that carbon-12 has 6 neutrons. Carbon-13 would have 7 neutrons, and carbon-14 would have 8 neutrons. And so if we divide these numbers out to find the ratio, we of course are going to get a ratio of 1 for carbon-12, and then I do need a calculator for carbon-13. 6 divided by 12 gives me 0.86, and then for carbon-14, 6 divided by 8 gives me a ratio of 0.75. And so the most stable isotope here is of course carbon-12 because it does have a proton to neutron ratio of exactly 1 to 1. And so we'll put, what is the most stable isotope? Carbon-12. Now on to the next one. Number 2 gives us 4 oxygen isotopes, and so we will start by doing the proton to neutron ratio for each, and this time instead of drawing out a whole table I'm just going to write it beneath. We know that all isotopes of oxygen have 8 protons, so I'll put an 8 under each of our isotopes. And then we just need to figure out our number of neutrons. So oxygen-12, if oxygen has 8 protons, that must mean that oxygen-12 has only 4 neutrons. Oxygen-14 would have 6 neutrons. Oxygen-16 would have 8 neutrons, and oxygen-17 would have 9 neutrons. And so right away, without even doing any math, we can go ahead and say that the most stable isotope is going to be this 1-to-1 ratio, so oxygen-16. And you can calculate out the values for the ratios if you want, but since the question just asked which one is most stable, I'm just going to stop there. The next section of this practice sheet is about alpha decay, and so it wants us to start by drawing the alpha particle symbol. And of course there are 2 ways that we can draw this symbol. We can either draw it as a helium nucleus with He, 4 mass number, 2 atomic number, or we can draw 4, 2, and then just use the alpha symbol. So either way is acceptable. As long as we have the same 2 numbers, we are going to get the same result of our equation, so it doesn't really matter which one we use. Now it wants us to apply that symbol and to figure out what will happen if all of these different isotopes undergo alpha decay. And so for each one of these, we are going to have to figure out what the atomic number is, because we know that alpha decay impacts both the mass number and the atomic number. And in the problem, it only is giving us the mass number. So we're going to have to look these up on our periodic table and figure out what the atomic number is. So for PT, so if we come over to our periodic table and find that, it's actually the one up here, and it's also right here. It's a little hard to read on this periodic table, so you may want to pull out one of your own so you can actually see the atomic numbers. But PT is atomic number 78, and so I'm going to go ahead and write out the full isotope symbol here, PT, with 78 on the bottom and then 199 on top. And so I know that when something undergoes alpha decay, one of the particles is of course going to be the alpha particle, and then the other particle is going to need to add to that alpha particle so that I get back to my original mass number and my original atomic number. So all I'm doing is asking myself, okay, what plus 4 will give me 199? And of course, that is 195. So our mass number is going to be 195. Now that doesn't tell us anything about what element this is, so we need to find the atomic number. So what plus 2 will give me 78? Well, that would be 76. And now that I have this atomic number right here, and I'll label this atomic number, now that I have that, I can come over to my periodic table and figure out what element symbol I need to put in. And so if we come over to our periodic table, number 76 is OS. So that will be my element symbol that goes in my isotope notation. And of course this is supposed to go in the blanks, so I will put my alpha particle 42, and then I can either put the full isotope notation like we've drawn down here, or I can just simplify that to say osmium 195, just like they did in the beginning of the problem. So either way is acceptable for this practice sheet. Alright, then in the next, number 2, we have osmium 191 undergoing alpha decay. So of course, we're going to start by drawing out our isotope symbol. OS 191 goes at the top, and of course we just looked up the atomic number of OS, so that is 76. So we can easily write that in. And it's undergoing alpha decay, so I'm going to get my alpha particle, and this time I'm going to do helium instead of drawing the alpha symbol. And we just need to figure out the other particle. So what plus 4 gives me 191? Well, that would be 187. And then what plus 2 gives us 76? Well, that would be 74. So then we need to go over to our periodic table and figure out what element number 74 happens to be. And that would be tungsten, which is a W, it's tungsten's chemical symbol. So there's my chemical symbol. And of course, when I fill in my blanks, I'll put my alpha particle. And then I'm just going to write tungsten 187, so the shorthand notation for that isotope. Up next we have Pm149 decaying, so we'll start by writing our full symbol notation for that isotope. So Pm149 is our mass number, so we just need to figure out our atomic number. If we take a look at our periodic table, find Pm, it's actually down here in the F block of the periodic table, and we'll talk more about that later. So if you find that on your periodic table, it is atomic number 61. So we'll fill in 61. And if it's undergoing alpha decay, we'll start with our alpha particle. Let's see. Whoop, I'm drawing my alpha particles incorrectly today. I had a little bit of brain fart there. There's my alpha particle, and then we just figure out our new mass number, new atomic number. So 149 minus 4, so 145 is our mass number. And our atomic number, 61 minus 2, gives us 59. And if we find element number 59 on the periodic table to figure out our chemical symbol, number 59 is PR, which I'm right down here in the F block as well. So PR, a little bit of technical difficulties there. And now we'll write our shorthand notation, our alpha particle 42, and then PR-145. On to number 4, we have PO211 undergoing alpha decay. So we'll start by writing our full symbol, PO211. And of course, PO's atomic number is number 84. It is right here on the periodic table. So we'll add in that atomic number of 84. And then when it undergoes alpha decay, it emits that alpha particle with a mass of 4 and an atomic number of 2. And we just need to figure out what that other particle is. So 211 minus 4 would give us a mass number of 207 as our new mass number, and a new atomic number of 82. So let's find 82 on the periodic table, and 82 is in fact lead, Pb, right here. So we'll fill in that chemical symbol, Pb, and we'll write our shorthand notation. Pb-207, lead 207, and then our alpha particle, 42He, or alpha, whichever you want to write. Alright, and our last alpha decay problem has bromine 80. So Br goes in our nuclide notation. Of course, our mass number of 80 goes at the top, and then we just need to find bromine on our periodic table. It is number 35. It is right here. It's one of the halogens, number 35. So we'll fill in that atomic number, and then if bromine's undergoing alpha decay, it emits an alpha particle. And we'll just figure out our new mass number and atomic number. So 80 minus 4 gives us 76. 35 minus 2 gives us 33, so we are looking for element number 33, which is arsenic, right here, arsenic. So we will put in that chemical symbol. Let's see, As. So now we will write into the blanks 42 alpha, and then arsenic 76.